In this lesson, we discuss equivalent statements. We start with the definition. Two statements are equivalent, and this is how we symbolize equivalence. It's an arrow going in both directions, but it's like a bold arrow, okay, with these like two lines here. So it's like a bold arrow going in both directions. Anyway, two statements are equivalent if both statements have exactly the same truth values in the answer columns of the truth tables. Just a side note, sometimes this symbol also is used to denote equivalence. It's kind of like an equal sign, but with an extra line. In this first example, we want to determine whether these two given statements are equivalent. The first statement says P and Q or R. The second statement says P and Q or P and R. Let's look at their truth tables. I would actually encourage you to pause the lesson here and construct the truth tables and then look at the answer columns for each table and make sure they match. So go ahead and do that now. All right, let's compare our truth tables. Does yours look like mine? I hope so. When I compare these answer columns, I notice that this statement here, which is a conjunction, has the same truth values as this statement here, which is a disjunction. Therefore, this statement is equivalent to this statement. All right, check out this example. Determine whether the following statements are equivalent. The first statement is, if you win your fantasy football league and you are here Friday, then we will celebrate. The second statement says, if you do not win your fantasy football league or you are not here Friday, then we will not celebrate. All right, there's three different statements here. We need a P, a Q, and an R. All right, I have all three simple statements represented, P, Q, and R. All right, so what we need to do is we need to write each one of these statements above in symbolic form, and then look at the answer column in their truth tables to see if they really are equivalent. All right, let's try the first one. All right, in symbolic form. If you win your fantasy football league and you are here Friday, then we will celebrate. This is a conditional statement. It's an if-then statement. If, here comes the antecedent. If you win your fantasy football league and you are here Friday, all of that is before the comma. All of that is the antecedent. And please notice the and. If you win your fantasy football league, that is P, and you are here Friday, that's Q. All of that together is before the comma. So all of this, if this happens, then, right, we need that symbol, then R. So that's your first statement in symbolic form. Now the second statement, if you do not win your fantasy football league or you are not here Friday, comma, then we will not celebrate. Once again, it's a conditional statement. Everything before the comma, before this comma right here, is your antecedent. All right, here we go. If you do not win your fantasy football league, so if not P, or that's a disjunction, you are not here Friday, so that's not Q. So all of that is before the comma. All of that is the antecedent. Then, so there's our symbol, we will not celebrate, then not R. So these are the two statements. All right, this is what I want us to do. Can you now pause the lesson once again, create or construct a truth table for this statement here, the first statement, and also for the second statement, and then compare the answer columns to see if these statements are equivalent. So after constructing the truth tables and looking at the truth values in their answer columns, I can see these statements are not equivalent. All right, cool deal. Let's move forward. In an earlier lesson, we looked at De Morgan's laws for logic, and here they are again, and it's super interesting. One law says that this statement here, the negation of P and Q, is equivalent to not P or not Q. It's almost as if, this is how I remember it, it's almost as if you distributed, all right, this negation symbol, like if you distribute it to P and you distribute it to Q, kind of like an algebraic move, something that you did in like algebra. If you distribute this negation symbol to both P and Q, it's going to negate P, it's going to negate Q, but what it's going to do to this symbol in the middle, it's going to make it, instead of a conjunction, it's going to make it a disjunction. So now you have not P or not Q. That's how I remember this law. Also, the second law is if you were to distribute it, right? It's going to be not P, not Q, but instead of a disjunction, you're going to have a conjunction. So that kind of helps me remember De Morgan's laws for logic. All right, check out this new example. We want to select a statement that is logically equivalent to, I do not have investments, but I do not have debts. So which one of the following is equivalent to that one? So we have, I do not have investments or I do not have debts. It is false that I have investments and I have debts. It is false that I have investments or I have debts. I have investments or I have debts. Which of the following is equivalent to the given statement? All right, the first thing I think we need to do is to write the given statement in symbolic form. So in order to do that, we need a P and a Q, all right? So I've chosen P to represent the statement I have investments, and Q, I have debts. Now the original statement says, I do not have investments, so that is not P, comma, but I do have debts. But remember, the word but here is one of our logical connectives. It can be replaced with and, so that is a conjunction. I do not have debt, so that is not Q. All right, so this is the given statement. This is the given statement. So what we're going to do now is we're going to rewrite each of these statements, A, B, C, and D, all of them in symbolic form, and use De Morgan's law to figure out which one is equivalent. All right? So for this one here, I'm going next to statement A. I do not have investments or I do not have debts. Let's go for that one. I do not have investments. That is not P. Or I do not have debts. So that's or, not Q. All right, the next one is it is false that. It is false that. So that's a negation of. I have investments and I have debts. So it is false that. That's the negation of P and Q. Next, it is false that. Let me change the color here. How about this? It is false that I have investments, that's P, or I have debts, okay? And then finally, the last one says I have investments, that's P, or I have debts. All right, so we have all of these in symbolic form. Now, I'm going to remind us that De Morgan's law says that this statement here, this original statement, right? This is the original statement. That is equivalent to, there's my symbol, that's equivalent to the negation of P or Q. Now that's from De Morgan's law. I'll scroll back up if it helps. Well, I'll try. There. It's this guy right here. Which one is it? Oh, this one here. This is the given statement, not P and not Q. That is the original statement that they gave us here. And it is equivalent to the negation of P or Q. And that's what I've written down for us here. The negation of P or Q. So then, therefore, it is this third statement here. Letter C. The given statement here is equivalent to it is false that I have investments or I have debts. Now they've given us a statement and they want us to come up with a statement that is logically equivalent. So here's the statement that is given. It is false that you can take trigonometry to meet your mathematics requirement, or you can take biology to meet your science requirement. All right, so let's do it, folks. Now, the first thing we should probably do, like normal, is start with a P and a Q. All right, cool. Now, the given statement says it is false that, so that's the negation of, open up a set of parentheses, it is false that you can take trigonometry to meet your mathematics requirement, so it is false that P, or you can take, you can take biology to meet your science requirement. So this is the given statement. By De Morgan's law, we know that this is equivalent to, I'm going to distribute that negation symbol, not P and not Q. So that would mean, not P would mean you cannot take trigonometry to meet your mathematics requirement. Not Q would be you cannot take biology to meet your science requirement. So there's our statement that is logically equivalent to the statement they gave us. Cool. I kind of wanted to draw these similarities between set theory and logic when it comes to De Morgan's laws. We saw De Morgan's laws first when we were discussing set theory, and now we're using De Morgan's laws as they pertain to logic. But it's very similar. The complement can be compared to the negation. All right. And this intersection can be compared to the and. Union can be compared to or. So union and or are equivalent. Intersection and are equivalent. And the complement and negation are equivalent. So just the similarities here between De Morgan's laws as they relate to set theory versus De Morgan's laws as they pertain to logic. You know, what's also interesting is we can rewrite a conditional statement, if P then Q, as not P or Q. That's really interesting. Or the other way around as well, not P or Q, this disjunction can be rewritten as a conditional statement if we wish. That's really cool. To illustrate this, let's look at this following example. All right, they've given us a statement that says the cows are in the pasture or the horses are not in the barn. We have to find a statement, a conditional statement, that is logically equivalent. Now, first of all, can we acknowledge that they have given us a disjunction? And I know that because of this word or right there. So they want us to take a disjunction and write it as a conditional statement. In other words, they gave us something on this side, right? A disjunction. They want us to write it as a conditional statement. All right. Now, the statement that they've given us can be written like this. If I can get my pen to work. All right, here we go. The cows are in the pasture, so that's P, or the horses are not in the barn. So P or not Q. Now, in order to write this as a conditional statement, I want you to notice what has changed and what has not changed, okay? First of all, our disjunction turns into this conditional symbol. But look at the first statement. Not P turns into P. Now, the difference between not P and P is it's been negated. In other words, they have opposite truth values. The truth value of not P is opposite of the truth value of P. Okay? So these two statements have to be opposite in truth value. But the second statement remains the same. So in other words, in order to change this disjunction to a conditional statement, I'm going to have to negate this first statement, right? And keep this guy the same. So it can be rewritten like this. Not P. And then the conditional symbol. And then not Q. So if not P, then not Q. All right. This would be symbolically the equivalent statement. All right. In words form, in words, it would be if the cows are not in the pasture, then the horses are not in the barn. That statement there is logically equivalent to the given statement. All right. So I hope that makes sense there. Now, this next example really has us exploring how do we negate a conditional statement? All right, so we're going to use one of De Morgan's laws to do this. The first thing we're going to do is we are going to start with this statement here. All right, start with this. If P, then Q. All right, if P, then Q. Now, we know that this is equivalent to not P or Q. You can look back at your notes. A little while ago, we said that we can write a conditional statement as a disjunction. So that's what we're using here. The next thing I want us to do is negate both sides. Negate both of these statements. Negate this statement, negate this statement. All right, so let's do that. When I negate this statement, I need to use parentheses because I'm negating the entire statement. But if I negate that side and I negate this side, then I still have this equivalence here. So I still have that equivalent symbol here. All right. Now this here is this statement that they are asking me to work with. So now this statement, which they gave me, is equivalent to this statement. But this is, let me just simplify this right-hand side. And this is one of De Morgan's laws. Remember we talked about how I want us to pretend like we're distributing this negation symbol, but what it's going to do is change this disjunction to a conjunction. So it's going to be the negation of not P. That means you're going to have P. And then and not Q. Therefore, this statement here that they gave you, right? This statement is equivalent to this statement. This, the negation of this conditional statement is a conjunction. I'd like to summarize that like more precise, okay? So maybe in your notes, you can add this. So the negation of a conditional statement becomes a conjunction, right? So the negation of if P then Q, this turns into a conjunction. This is equivalent to P and not Q. This is important. Okay, this is when you negate a conditional statement, it is equivalent to this type of conjunction here. Now, the following is very important, all right? So we take a conditional statement, if P then Q, and you can basically find other statements that are equivalent to it, all right? And there's many. And it's all about changing the antecedent or switching the antecedent and the consequent. If you move P and Q around in the statement, if P then Q, remember, P is called your antecedent and Q is called your consequent. If you switch them, or if you negate one of them, or both of them, it's going to create another kind of statement. And so that's what we're talking about. So these are different variations of this conditional statement. Let's start with if P then Q. All right, so the conditional statement, if P, then Q. That's like the basic conditional statement. Now, what would be considered the converse? The converse, and this word here is so important in the study of mathematics. The word converse means you just switch the antecedent and the consequent. So if you switch the antecedent and the consequent, it means if Q, then P. See, we just switched them, the antecedent and the consequent, and now we have if Q, then P. That's the converse. Now, the inverse of if P, then Q means you're going to negate the antecedent and you're also going to negate the consequent. So in other words, the inverse of the conditional would be if not P, then not Q. And then last but not least is the contrapositive. The contrapositive of if P, then Q, what it does is it switches the antecedent and the consequent. So now Q is going to be in the front and P is going to be on the back end, but it also negates both. So it's going to be if not Q, then not P. That's the contrapositive. All right, so we have all four, okay? All right, cool deal. Now, the question we really want to answer is, are any of these variations of the conditional statement equivalent? So you would have to construct a truth table to see this. But when you do, it reveals that the conditional statement, if P then Q, is equivalent to, are you ready? Which one of these three do you think it is? If P then Q, is it equivalent to the converse? Is it equivalent to the inverse? Or is it equivalent to the contrapositive? This conditional statement is equivalent to the contrapositive statement. And then the converse and the inverse, these two are equivalent. So that's really cool, and it helps us understand statements and their truth value. Again, if you want to prove either one of these, just construct a truth table and compare the truth values. All right, they've given us a conditional statement. If the painting is Andy Warhol, I'm not sure I'm pronouncing that last name correctly, but if the painting is from Andy, then the painting is valuable. For that statement, that conditional statement, write its converse, write its inverse, and then write its contrapositive. All right, first of all, I'm letting P represent the painting is by Andy. Q represents the painting is valuable. All right, so we have this statement: if the painting is, you know what, up here, folks, I forgot the word by. Can I insert that? I'm not sure. I hope I read it correctly, but let me just add it really quickly. Make sure you have it in your notes. There we go. The word by is not. If the painting is by Andy Warhol, then the painting is valuable. All right, very good. All right, the statement that they gave us is if P, then Q. All right. All right, so for the first one, the converse. Remember, the converse means that you just switched the antecedent and the consequent. So it will be if Q, then P. In words, if the painting is valuable, then the painting is by Andy Warhol. That's the converse. Let's go for inverse. Remember, the inverse means we're going to negate the original antecedent and negate the consequent. So it'll be not P implies, or not P, excuse me, if not P, then not Q. That would be read as, if the painting is not by Andy Warhol, then the painting is not valuable. All right, finally, the contrapositive. Remember, the contrapositive of if P then Q is going to have us switching the antecedent and the consequent, but also negating them as well. So the contrapositive would be if not Q, then not P. Let me move the board up a little bit here, like that. All right, in words, if the painting is not valuable, then the painting is not by Andy Warhol. All right, that is really good work there. And a good takeaway is to just reiterate that the original statement, if the painting is by Andy Warhol, then the painting is valuable, that's equivalent to saying, if the painting is not valuable, then we can conclude the painting is not by Andy. So the original statement is equivalent to this last one, the contrapositive here. All right, use the contrapositive to write a statement logically equivalent to, if you don't eat your meat, then you can't have any pudding. All right. All right, I have my P and my Q. The given statement is, if you don't eat your meat, so if not P, then not Q. All right. Now remember that the contrapositive switches the antecedent and the consequent. In addition, it negates both of them. So then the contrapositive will be the negation of the consequent is now the antecedent, and then your symbol for a conditional statement, and then the negation of the antecedent is now your consequent. In other words, if Q, then P. In words, the contrapositive is read as, if you can have any pudding, then you do eat your meat. This is so valuable that we're able to take a statement and come up with its contrapositive. In other words, a statement that is logically equivalent to it.